the things because I didn't involve in a research problem, I cannot give you exact answer.
Alright.
And I just give you my perspective from the outside. So the idea is a very, it's the whole research program happens during 1 year, in 2 semesters based on the German system, and 1 semester is completely research, study, made a model, and in other semester they just try to make it real, one-to-one prototype. So this is the whole process happens with the collaboration between different institutes, different universities, from biology to architecture and structural engineering, to find and teach the students how they can just grab the idea, inspired from the biology, develop it into the design principle, computational design, and also they just, on the other hand, they need to look at structural principles. So when they learned how to deal with these, like you can say these 3 principles, they started to develop their models, the idea of the design. And after that, this idea goes for the next step to be fabricated. About the computational design, there is 2 levels. One level is for bachelor students, another one is for master students. The bachelor students, they are going to become familiar with the associative and algorithmic design, or we can say the visual programming, which is embedded inside the Rhino, and one CAD system, and basically is a grasshopper. So they are going to understand that in CAD system, also they can just use different kind of idea to explore the design. And it is for the bachelor student. It's just they are going to be familiar with the algorithmic thinking, how they are going to structure the idea from scratch with a recipe, adding things together and generate something, sometimes more than the parts. But for the master, it's a little bit more advanced, and it's started from scratch, teaching Python as a scripting technique inside the Rhino. When they, after they learn the basic of the Python programming, they are going to understand a little bit advanced to the object-oriented programming. After object-oriented programming, I'm teaching them the way that they can use this idea inside the architecture, different kind of algorithm that develop from the complex system to the cellular automator, L system, branching, recursion, wormhole, all of them. They are going to see, okay, for example, this algorithm, this is the source code of them, and how they can program. When they become in this way of thinking, then I'm going to give you another idea. The main principle is going to be given to them, and you're going to start to develop the main idea for them. Sometimes it is related to the project, sometimes it's not, sometimes it's completely separate. Recently we started to think about that, okay, how we can just in my course, how we can just use this prototyping machine, for example, 3D printing, laser cutting, to use inside the course. So they develop the idea and they build it with a 3D printing, or they build it, cut it with laser cutting and assemble it. For example, for the midterm project, they was limited to use flat sheet. So this limitation influenced their design. So whatever they are going to design, it should be followed with a paper structure. But for the final project, they are free. They can use 3D printing. They can use every kind of digital fabrication tool that they know to build their idea. So this is the whole idea of the computer design.